Alright guys, today we're going to do section 3 of unit 5, and this is solving systems by elimination. And this is just another method. We've solved it by graphing and we solved it by substitution. And with this method, the goal is to get one equation that only has one variable. Okay, the coefficients, that's the number in front of your variable, of one variable must be exactly the same or opposites for this to work. Okay, so instead of talking about the steps, we will come back to that. I'm going to show you how to do this. Alright, so on this first one, you can eliminate by adding, subtracting, or multiplying. So on this lesson we're going to talk about adding and subtracting. And let's look about adding on this. So see how on this equation, if I go ahead and add my coefficients, and then on the next one, if I add these two equations, this -1 and +1 is going to cancel out. And that's why at the beginning, with one of our statements, it says the coefficients of what variable must be exactly the same or opposites. If they're opposites, you can add them because they're going to cancel out. Okay, so let's do this. 1x plus 1x is 2x. A -1y plus a +1y cancels out. 7 plus 3 is 10. Now I'm going to solve for my variable x. Okay, so remember the solution is that point, and my x coordinate is 5. Once you find what one of the coordinates are, you can, or which one of the coordinates is, you can substitute it into either equation. And I think I'm going to use the second equation so I don't have to deal with the subtraction here. So I'm going to take x plus y equals 7. I'm going to substitute in for x, and now I can solve for my variable y. By isolating that variable, subtract 5, so y equals 2. Now, I do want you to check these, even though it doesn't say check. I want you to make sure you're correct on this, and this is what we did for the very first unit of this lesson. So by checking, we can check and see if this point is on each line here. So for my first equation, substitute 5 in for x, y for 2, 2 for y, sorry about that. So I have 5 minus 2, and I get a true statement. Okay, we got to check the second equation. I have x plus y. So x is 5, y is 2. And when I simplify the left side, because the right side is already simplified, I get a true statement. So I know that this is my solution to those systems. And I did this by adding. Okay? So let's go back up and look at the steps. Sometimes y'all like to look at steps to help you. So here's what you do. Write the system so that the like terms are lined up. Okay? So you got to make sure that your x's are lined up, your y's are lined up, and your constant is lined up. Alright? Add or subtract. So if you have, and we'll talk about subtraction in a minute, if you have opposites, what you can do is you can add them. Solve for that one variable, substitute into either equation to solve for the second variable, and then check your answer. Okay, let's do another one. Now on this one, we have 1x minus 2y equals 0, and 2x plus 2y equals 12. So you need to decide, are we going to add or subtract? Well, I have opposites here. I have a -2y and a +2y. You know they're going to cancel out if I add. So let's add. 1x plus 2x, 3x. These cancel out. 0 plus 12 is 12. Solve for your variable. Okay, so my first coordinate is 4. And again, I think I'm going to pick the second equation so I don't have to deal with that negative number. So I'm going to do 2x plus 2y equals 12. And I'm going to substitute in for my variable x. And solve this equation by isolating my variable y. So I get my y coordinates as 2. Okay, now let's check and make sure. So I'm going to substitute 4 in for x and 2 in for y. Simplify both sides. My right side is already simplified. And when I simplify both sides, I get a true statement. Now we've got to check that second equation. So substitute in for your x and y. Simplify. And I get a true statement. So I know that this point is the solution to these systems because that point is on both lines, and when you graph those lines, they intersect in that one point. Alrighty, let's go to the next one. Now, on this one, class, notice how I don't have opposites. I have a 2, positive 2, positive 2. I have a 5 and a negative 2. I'm looking at my coefficients in front of my like terms here, okay? So on this one, what we're going to do is we're going to subtract. Okay, so when you subtract, let's act like we're distributing that negative 1. Okay, so what we have here on this second one is we have negative 2 times, or negative 1 times 2x is negative 2x. Negative 1 times a negative 2y is a positive 2y. Negative 1 times 0 is 0. Okay, so you want to distribute that because you never subtract, you always add its opposite. So the opposite of a positive 2 is a negative 2. Opposite of a negative 2 is a positive 2. And 0 is neither, so it stays 0. So what we're doing on this one, let me move over here, is we've got our first equation and our second equation. And we are now adding. So these cancel out. They're opposites. So 5 plus 2 is 7. Therefore, y is 1. Okay, now let's substitute in. Now I'm going to use the first equation here. I'm going to substitute in for my y. Go ahead and do my point. Okay, so I have 2x plus 5 equals 7. Subtract 5, because I'm trying to isolate that variable x, and divide by 2. Okay, so let's go over here and check it. First equation. 2x plus 5y equals 7. Substitute in for x. Substitute in for y. So I have 2 plus 5. And 2 plus 5 does equal 7. Okay, then we got to substitute into the second equation. I have 2x minus 2y equals 0. Substitute in for your x. Substitute in for your y. 2 minus 2. And that does equal 0. All right, last one. Okay, are we going to add or subtract? We can add if we have opposites. We don't have opposites, so what we're going to have to do is we're going to have to subtract. So, I have 1x plus 3y equals 7. And I have 1x plus 1y equals 5. And we are going to subtract. So, when we subtract, we add its opposite. So what I did here is I added, instead of a positive 1, it's a negative 1. Instead of a positive y, it's a negative y. Instead of a positive 5, it's a negative. I just distributed that negative 1. So I have 1x plus 3y equals 7. I have negative 1x minus, or plus negative 1y equals a negative 5. And we are now adding because we changed the subtraction to addition, okay? So these are opposites. They cancel out. 3 plus a negative 1 is 2y. 7 plus a negative 5 is a positive 2. Solve for your variable y. Now let's substitute it in. I'm going to use this equation because I don't have to deal with that 3 here. So x plus y equals 5. I'm going to substitute in for y. So x equals 4. So we're saying the solution here is 4, 1. Make sure you list your x coordinate first and then your y coordinate. So let's double check and make sure we're right. Alright, let's substitute in for our variables. Simplify, so you can't simplify anymore. And then for our next one, so we got it. So this is your lesson on solving systems by elimination by using addition or subtraction. And tomorrow we'll do elimination by multiplying. So guys, have a good evening.